Okay, the blockchain is new hot technology. If you haven't heard about it, you probably know about Bitcoin. Well, the blockchain is the underlying technology that powers Bitcoin. Experts say the blockchain will cause a revolution similar to what the internet provoked. I personally think it's more like Linux than internet, but that's a separate discussion. What is it really? How can it be used to build apps today? There's various blockchains that have been created, and you can build apps on some of them, such as on Ethereum. This post is the first in a series of 3 explaining the blockchain phenomenon to web developers. We will discuss the theory, show the actual code, and share our learnings based on real-world project. But let's start with what are blockchains really? So what a blockchain is. Although the blockchain was created to support Bitcoin, the blockchain concept can be defined regardless of the Bitcoin ecosystem. The literature usually defines a blockchain as follows. A blockchain is a ledger of facts replicated across several computers assembled in a peer-to-peer network. Facts can be anything from monetary transactions to content signature. Members of the network are anonymous individuals called nodes. All communication inside the network takes advantage of cryptography to securely identify the sender and the receiver of the facts. When a node wants to add a fact to the ledger, a consensus forms in the network to determine where this fact should appear in the ledger, and this consensus is called a block. So, okay, maybe that was confusing, but let's go a bit deeper and hopefully you'll start understanding it a little better. So the first thing is ordering the facts. So we're going to store these facts in a decentralized peer-to-peer network. We have seen examples of these before, such as Kazaa, Napster, BitTorrent, and others. So instead of exchanging movies in these peer-to-peer networks, now we're going to have these members of the blockchain network exchange facts. So what's the real deal with that? You can think of exchanging facts like, the facts about who owes who how much money, and so we can keep all our financial tracking in a distributed way. So peer-to-peer networks, like other distributed systems, have to solve a very difficult computer science problem, which is the resolution of conflicts about these facts, or reconciliation. And relational databases offer referential integrity, but there's no such thing in a distributed system. And so if 2 incompatible facts arrive at the same time, the system must have rules to determine which fact is considered valid. So take, for instance, the double spend problem. So Alice has $10, and she sends twice, $10 to Bob and $10 to Charlie. So who will have the $10? To answer this question, the best way is to order the facts. If 2 incompatible facts arrive in the network, the first one to be recorded wins. So in a peer-to-peer network, 2 facts sent roughly at the same time may arrive in different orders in distant nodes. So how can the entire network agree on the first fact? So to guarantee integrity over a peer-to-peer network, you need a way to make everyone agree on the ordering of the facts. You need a consensus system. So consensus algorithms for distributed systems are a very active research field, and you may have heard of Paxos or Raft algorithms, and the blockchain implements another algorithm, the proof of work consensus, using blocks. So let's talk about blocks. So blocks are a smart trick to order facts in a network of non-trusted peers. So the idea is simple. Facts are grouped in blocks, and there's only a single chain of blocks replicated in the entire network. Each block references the previous one. So if fact F is in block 21 and fact E is in block 22, then fact E is considered by the entire network to be a posterior to fact F, or later to fact F. So before being added to a block, facts are pending or unconfirmed. So in this diagram here, we can see that there's fact H, fact K, J, L, and M, which are pending, and then facts E, G, and I have been placed on this block 22. These are the confirmed facts, and they're attached in a blockchain. And the chain can be verified using some cryptography, but that will be later. So, mining. So, some nodes in the chain create a new local block with pending facts. And then they compete to see if their local block is going to become the next block in the chain for the entire network. So it's kind of like every individual has their own idea of what the next block should be, and then they compete to make that the official next block. And they do this by rolling dice. So if a node makes a double 6, then it earns the ability to publish their local block, and all facts in this block become confirmed, let's say. So here's one local computer, node 443, which came up with this block 23, node 772 and 281 came up with this idea for block 23. And then they all roll dice. Node 443 wins the dice roll, and then they all accept node 443's block 23 as the fact for all of them. And then this block is sent to all the other nodes in the network, and all the nodes check that the block is correct by doing cryptographic verification of keys, and they add it to their copy of the chain, and then try to build a new block with the new pending facts. So whatever else is pending, they try to create a new block and roll the dice to win their version of the next block in the chain. And these nodes don't just roll a couple dice, there are challenges implying rolling a huge number of dice. Finding the random key to validate a block is very unlikely by design. And this prevents fraud and makes the network safe unless a malicious user owns more than half of the nodes in a network. I think it's about a third, but okay, let's just say it's half. As a consequence, new blocks gets published to the chain at a fixed time interval. In Bitcoin, blocks are published every 10 minutes on average. So in Bitcoin, the challenge involves a double SHA-256 hash of a string made of pending facts, and the identifier of the previous block and a random string. And a node wins if their hash contains at least n leading zeros. So if these are the two hashes that have been submitted, the second hash would win because it has at least 10 leading zeros here. Okay, so the number n is adjusted every once in a while to keep block duration fixed despite variations in the number of nodes. This number is called the difficulty. So other blockchain implementations use special hashing techniques that discourage the use of GPUs by requiring large memory transfers. The process of looking for blocks is called mining. This is because just like gold mining, block mining brings an economical reward, some form of money. That's the reason why people give up their computers or run nodes in a blockchain, and they are called miners. So by default, a node doesn't mine, it just receives blocks mined by other nodes, and it's a voluntary process to turn a node into a miner node. Now, money and cryptocurrencies. So every second, each miner node in a blockchain tests thousands of random strings to try and form a new block and compete to make that the block for the network. So running a miner in the blockchain pumps a huge amount of computer resources such as storage and CPU. And that's why you must pay to store the facts in a blockchain. And reading facts, on the other hand, is free. You just need to run your own node and you'll recuperate the entire history of facts, or the entire blockchain issued by all the other nodes. So to summarize, the reading is free, adding facts costs a small fee, and mining a block brings in the money of all the fees of the facts included in the block. And we're not talking about real money here, but the blockchain has its own cryptocurrency. So in the case of Bitcoin, BTC, Bitcoin Network, or in the case of Ethereum, it's Ether, ETH, and so on. There are many more cryptocurrencies, but these are the two more popular ones. To make a payment in the Bitcoin network, you must pay a small fee in Bitcoins, and just like you would pay a fee to the bank. So where do the first coins come from? So miners receive a gratification for keeping the network working and safe. Each time they successfully mine a block, they receive a fixed amount of cryptocurrency. In Bitcoin, this gratification is 25 Bitcoins per block. In Ethereum, it's 5 Ethereum per block, 5 Ether per block. So that way, the blockchain generates its own money. Lastly, cryptocurrencies rapidly become convertible to real money. Their face value is only determined by supply and demand, so it's subject to speculation. At the time of the writing, mining Bitcoin still costs slightly less in energy and hardware than you can earn by selling the coins you discovered in the process. And that's why people add new miners every day, hoping to turn electricity into money. But fluctuations in the Bitcoin value make it less and less profitable to be a miner. Okay, so this is what the Bitcoin chart looked like until, February 2016, maybe March 2016. But now we know right now it's been rising in the last month, and the price is nearly $3,000 at this point. So as you can see, since in 2016 it was only about 500. So okay, contracts. So far we've mostly mentioned fact storage, but a blockchain can also execute programs on the network. Some blockchains allow each fact to contain a mini program. Such programs are replicated together with facts, and every node executes them when receiving the facts. So in Bitcoin, this can be used to make a transaction conditional. So Bob will receive 100 Bitcoin from Alice if and only if today is February 29th. So that's the program. So if today is February 29th, then Bob will receive 100 Bitcoin, otherwise he won't. So you can set up, conditions or programs on the blockchain. Other blockchains allow for more sophisticated contracts. In Ethereum, for instance, each contract carries a mini database as well and exposes methods to modify the data. So as contracts are replicated across all the nodes, so are their database. And each time a user calls a method on the contract and therefore updates the underlying data, this command is replicated and replayed by the entire network. This allows for a distributed consensus on the execution of a promise. And this idea of pre-programmed conditions interfaced with the real world and broadcasted to everyone is called a smart contract. A smart contract is a promise that signing parties agree to make legally enforceable. A smart contract is the same except with the word technically instead of legally. So this removes the need for a judge or any authority acknowledged by both parties. So contracts are legal contracts and smart contracts are technical contracts. Okay. Imagine that you want to rent your house for a week and $1,000 with a 50% upfront payment. So you and the loaner sign a contract, probably written by a lawyer. You also need a bank to receive the payment. At the beginning of the week, you ask for a $5,000 deposit, and the loaner writes a check for it. At the end of the week, the loaner refuses to pay the remaining 50%. You also realize that they broke a window, and the deposit check refers to an empty account. So you'll need a lawyer to help you enforce the rental contract in a court. So smart blockchain contracts allow you to get rid of the bank, the lawyer, and the court. Just write the program that defines how much money should be transferred in response to certain conditions. So 2 weeks before the beginning of the rental, transfer the $500 from the loaner to the owner. And then if there's a cancellation by the owner, then transfer $500 from the owner to the loaner. At the end of the rental period, transfer $500 from loaner to the owner. The deposit, give it back. Proof of physical degradation after the rental period, transfer $5,000 from loaner to owner. So you can write up this set of rules in the blockchain program, and this becomes a smart contract, and the technology will handle this for you, and you don't have to worry about defaults and somebody going back on their word or their promise and violating the contract. So using this smart contract in the blockchain, you're all set. At the time defined in the contract, the money transfers will occur. And if the owner can bring a predefined proof of physical degradation, they get the $5,000 automatically without any need for a deposit. So you might wonder how to build a proof of physical degradation. That's where the Internet of Things kicks in, IoT. So in order to interact with the real world, blockchains need sensors and actuators. And the blockchain revolution won't happen unless the IoT revolution comes first. So the IoT revolution might be able to say, oh look, the window is broken because there's some kind of a window sensor. Now, such applications relying on smart contracts are called decentralized apps or DApps. Smart contracts naturally extend to smart property and a lot more smart things. The thing to remember is that smart means no intermediaries or technically enforced. So there's no lawyers and courts and things like that, but rather these things are all technically enforced using blockchain or IoT or databases and so on. So blockchains are a new way to disintermediate businesses, and just like the internet disintermediated music distribution, we can disintermediate things like rental contracts, Uber contract, anything you can think of. Lending money, banking. So the blockchain basically replaces the trusted intermediary, and the typical cost of having lawyers and judges and courts can be much higher than having some servers and computers doing these things. So what is blockchain? Take two. So the best way to understand a blockchain is to look at it from various angles. What it does, a blockchain allows to securely share and or process data between multiple parties over a network on non-trusted peers. Data can be anything, but most interesting uses concern information that currently requires a trusted third party to exchange. Examples can be money requires a bank, proof of property requires a lawyer, loan certificate. In essence, the blockchain removes the need of a trusted third party. So an application can be if Russia and China want to trade, before they would use the US as the trusted third party to use the US dollars as the exchange medium. But with a blockchain, they can just go and trade and use the technology to be the third party. And how this works from a technical point of view, the blockchain is an innovation relying on three concepts: peer-to-peer networks, public key cryptography, and distributed consensus based on the resolution of a random mathematical challenge, like the one we saw earlier. None of these concepts are new, and it's their combination that allows a breakthrough in computing. And if you don't understand it all, don't worry. Very few people know enough to be able to develop a blockchain on their own, which is a problem, and we need more developers and so on. But not understanding the details of blockchain doesn't prevent you from using it or building apps on an existing blockchain network like Ethereum or something else. And you can do that just as you might build iPhone apps or web apps or some other kind of apps without knowing the TCP protocols of the internet, or more about certificate authorities and so on. So what it compares to. So see the blockchain as a database replicated as many times as there are nodes, or programs replicated as many times as there are nodes, loosely synchronized, or as a supercomputer formed by the combination of CPUs and GPUs of all its nodes. And you can use the supercomputer to store and process data just like you would with a remote API. So we can have various blockchain APIs. If you're a web developer or some other, iPhone developer, you can use those APIs to build up your blockchain applications without necessarily building the blockchain itself. And the only thing is you don't own the back end, but that's fine. You just need to be sure that the data is safe and processed properly in the network. This diagram here is just showing how you can view the same object in two different ways depending on where you see it from. Okay. Practical implications. Facts stored in the blockchain cannot be lost. They're there forever, replicated as many times as there are nodes, and even more, the blockchain does not simply store a final state, it stores a history of all the past states so that everyone can check the correctness of the final state by replaying the facts from the beginning. That is, the entire chain is stored and all the blocks are stored and so on. And so facts in the blockchain can be trusted as they're verified by a technically enforceable consensus, and even if the network contains black sheep, you can trust its judgment as a whole. And storing the data in the blockchain is not fast, as it requires a distributed consensus, and it takes a while for all the pending confirmations to happen. So if you have some time, there are other YouTube videos which you can also watch. I'll post a link to this video below. Now, why is it a big deal? The blockchain is the most disruptive technology I've ever seen, and there's some testimonials here. It can replace a lot of government functions. It's intellectually interesting, and so on. And the blockchain can potentially replace all the intermediaries required to build trust. And some of the examples can be like Monograph lets authors claim their work and set their rules. Lazoo is a decentralized Uber with blockchain, sharing your car, find a seat without Uber taking the fee. Augur is an online bookmaker. Storage.io is a peer-to-peer storage system. You rent your unused disk space or find cheap online storage. Muse is a distributed, open, and transparent database tailored for the music industry. Ripple enables low-cost cross-border payments for banks. Honestly, if you start using things like Bitcoin and Ethereum, you can go across borders anyway. And it's truly an international currency at this point. There's tons of non-financial use cases, whether it's for real estate or, gold, silver, other metals, for reviews, endorsements, e-commerce, IoT stuff, app development, all kinds of stuff. All kinds of financial use cases as well, and gaming use cases. And so many successful businesses on the internet today are intermediaries, and blockchain can help change a lot of that. And you can think about Google for a minute. Google is kind of the intermediary between you and the entire internet as a search engine. Or Amazon is an intermediary between sellers and buyers of any type of good, and a technology that allows you to remove intermediaries can potentially disrupt the entire internet. So this is kind of the thing. You won't be building your own blockchain. This is a list of some of the blockchains here: Ethereum, Hyperledger, Eris Industries, and you can play with these technologies, build your own stuff on them if you like. Bitcoin is not exactly something you'd build an application on. It's designed for money transactions and nothing else, but it's good at that. And miners often select transactions with the highest fees, so money transfers in Bitcoin become more expensive than they are in a bank. And the developer community is at war over all these things, and there's a lot of speculation and so on. How big are the blockchains today? Bitcoin is the largest one, but it takes more time. Block time is 10 minutes. Ethereum's block time is 10 seconds. It's smaller. Their Bitcoin value is almost $420. Ethereum's Ether value is around $10, but it varies quite a bit. This is in 2016. It's changed now. Bitcoin's value now is $3,000 and Ether is $250. So that is a small tutorial on blockchain. There's all kinds of things to explore, and hopefully that gives you a good introduction. This is Aditya Mittal, and one of the things I want to mention, in addition to everything I've just said, is the cryptography on blockchain. There's a risk that in the future things like quantum computing or these things might actually be able to break some of the cryptography on current blockchains, and some solutions have been proposed by Russian scientists and so on for how to do this on a quantum internet and so on and so forth. But I won't get into too much more details on that. And hopefully you've learned a few things about blockchains, such as what smart contracts are, what miners do, what are blocks, and how blocks are democratically or through some algorithms and challenges selected, and how miners earn their fees, and how this technology connects to other new technologies such as big data or IoT. And this is the future. So that's it. Good luck learning more about blockchain or building out your own blockchain applications.